events that we were looking at. So, here we go. Let's see. There. Okay. So, it's been a while. We were talking about probabilities last time. It's been a few days. I'm sure your brain kicked off for the weekend. Yes. Can I steal my pencil? Why? Usually when people have no intention of keeping that. Well, come on. Why is this not supposed to do? Here we go. Sometimes technology doesn't want to work. All right, so this is what you guys started with the other day, yes? Good. Go to your Google Classroom, and you will find an updated version of this. Okay? So let me pause this here. Freeze this. So there isn't much difference, but you will find some differences. Okay, good. Give me about 30 seconds. The draft did not get saved. Yeah, I know. Bummer. But you're in luck because now it's uploaded. So if you're in Google Classroom, just give a refresh and you should see it. Okay. Now, it doesn't look much different from the beginning because the first thing I said, I just added to it. We've gone through mutually exclusive and mutually inclusive events. So, refresh my brain. What does mutually exclusive mean? There's no overlap. Okay, there's no overlap. So, as opposed to what? They don't relate. Okay, they can happen. Can they happen at the same time? No. Okay. Right. Well, let's not confuse some of these words. They cannot have anything in common. Okay. They cannot have anything in common. How about mutually inclusive?
The opposite.
What do you mean opposite?
The opposite is the same.
Completely opposite? Not quite. So let's not think about these in terms of opposites of each other. So mutually, which one?
Inclusive.
If we have two events, A and B, which one does this represent?
Exclusive.
Exclusive. Okay, so this is mutually exclusive. So then mutually inclusive would be what?
They overlap each other.
Okay, so we had two instances that we talked about. Could be that where you had this overlap, but it also can be something like this. Okay, where the second event is completely contained within the first event. Okay, so both of these situations are mutually an example of a mutually inclusive event. Okay, hope everything was all right there. All right, now, calculation-wise, what did we say the formula for mutually exclusive events was? Calculating the probability.
P bracket A or B is equal to P bracket A plus P bracket B.
So in this case, the probability of A or B is equal to
Probability of A plus probability of B.
probability of A plus the probability of B. Well, mutually inclusive then would be probability of A or B would be calculated how?
Probability of A plus probability of B minus the probability of the set of A and B. Intersection.
The intersection. Okay? Oops, not plus, carried away. Minus, okay? So when we are looking at this, if we want to find the probability of A or B happening, we add the probability of A and the probability of B. If we look at this situation or this one, and we're trying to calculate the probability of A or B, we add them, but then we subtract out one of the overlaps. Why?
Because it is double.
Right, we don't want to double up that intersection. We don't want to double up the overlap. Good. And that's where we left off the other day. Okay, and we did some of these with the cards. We did the bag and we did the appliance, yes? Awesome. And then your homework was these problems. Questions? Can we do number 10? Sure. All right. So we have number 10. A bag containing cards numbered 1 to 14. One card is drawn at random, 5 with the probability of selecting a prime number or a multiple of 4. What are our two events?
One word card and
So the two events are what?
the card is random
Not the card in the red.
One.
Prime number
and multiple.
is, what's it then be?
Multiple.
Multiple of 4. So if we look at that, we look at all of the possibilities for A happening. Well, A is a prime number. What are the prime numbers?
One.
Oh,
No, it's like,
1 is not a prime number.
2.
2 is a prime number. 1 is not prime nor composite.
3.
Is 3 prime?
Yeah.
3 is prime.
4 is
5.
4 is not.
5.
5. 7. 8, 9, and 10, are they prime? No, they have more than 2 factors. So 11,
13, 14.
13. Well, we're only going to 14, so we know 14 is composite. So that's event A. Now, what about a multiple of 4?
2.
Is 2 a multiple of 4? 4, 8, and 12. Can't go 16. Why can't we go 16? Because there are only 14. Okay, so we got 40 and 12. Well, to help you visualize this, is there any overlap? We could do a Venn diagram and we'll put those, but I can also look at the outcomes for A. Are any of the outcomes for A repeated in the outcomes for B? No. So is it mutually inclusive or exclusive? So how do we find the probability?
The first one.
First,
Probability of A.
what is the probability of A?
6 out of 14.
6 out of 14. What's the probability of B?
Yeah.
9 out of 14.
That's it, sure.
That's it. I do not do anything else. Okay, because this is it. Remember, we established that these are mutually exclusive, so all I have to do is add the probability. That's it. So what are you putting in the bad one?
I'll use it.
Okay,
You can use it, just, it can't.
all right. Well, that's A. How about B, selecting a multiple of 2 or a multiple of 3?
Let's see. 2, 4, 6.
Well, our A's and B's change. So what's A? What are we looking at?
2, 4, 6, 8. Even numbers.
2, 4, 6, 8, 10, 12, 14, and 14. How about a multiple of 3?
3, 6, 9, 12.
3, 6, 9, 10, 12.
It's inclusive because it has 6 and 4.
Because, ladies, exclusive or inclusive? That got your attention, didn't it? Excuse me? How do you know it's inclusive? Because we have an overlap, because we have 6, 6, 12, 12. So we know that it's going to be which one? The second one, mutually inclusive. Okay? Is it this where they just have an overlap, or is B completely contained? It's a slight overlap because there are things in B that are not in A. Okay, this is saying that everything in B is in A. That's not the case. So, do we just add them together?
And we added together, yeah, we subtract the.
So, we add them together and subtract the intersection. So, what is the probability of A?
17 out of 14. 7 out of 14.
7 out of 14. And the probability of B? 1, 2, 3, 4 out of 14. And then we subtract. 7 and 4 is 11, minus 2. Selecting a 3 or a 4. Inclusive or exclusive? Exclusive. So, should be able to calculate those. 2 out of 14 or 1 out of 7. Okay. Selecting an 8 or a number less than 8.
So 8.
Is that inclusive or exclusive? Inclusive or exclusive? Why exclusive? Because it says strictly less than. It doesn't say less than. Our people do, it's just less than. So I can't select an 8 and at the same time select a number less than 8. So this is exclusive. Well, this is just another way of saying what's the probability of selecting a number equal to or less than 8. Well, how many numbers are less than or equal to 8?
7. Or 8.
Which one? 7 or 8? 8. So it is 8 out of 14. Because you have 7 out of 14 that are less than 8, and then you have 1 out of 14 that is equal to 8. So when you add them together, you get 8 out of 14. Well, 8 out of 14 is the same 4 out of 7. Keep in mind, for your IB, they are changing that. You used to be able to leave it as 8 out of 14. They want you to start to reduce these simple fractions. They want simplified fractions. Okay. Any other ones out of these that we might want to take a look at? This man. Is that 9?
Number 6.
Weather forecast. Weather forecaster states the probability of rain is 3 out of 5, the probability of lightning is 2 out of 5, the probability of both is 1 out of 5. What is the probability of the sporting event being canceled due to rain or lightning? Well, is this exclusive or inclusive?
Inclusive.
How do you know inclusive?
Because
What? Because of the word both. Okay? Since it says that both can happen, there's a probability that both can happen, then we know it is inclusive. Well, if it's inclusive, I know I'm dealing with this situation. So we know that we are dealing with this situation. So this is the probability of that is 1 out of 5. Well, probability, let's see. Let's go rain, let's go both, and let's go lightning. Both is 1 out of 5. What's the probability of, well, let's just go order. Rain. Probability of rain, 3 out of 5. Well, if it's just rain, 3 out of 5, but low is 1 out of 5, so what's the probability of just rain? 2 out of 5. Well, what about lightning?
1 out of 5.
How'd you get 1 out of 5?
Because there's 2 out of 5.
2 out of 5 is lightning. Well, that includes this, so that's 2 and the whole thing. If one of them is an overlap, then this has got to be 1 out of 5 out there. So, what is the probability of a sporting event being canceled due to rain or lightning? Well, if I work backwards like this, what do I do with these 3 probabilities? Add them up. Well, do I have to subtract anything out? No, because it's already been subtracted out. What do I know when I add all of these things together?
You get 2 out of 5 also.
I get the part that I'm looking for. Okay, well, how many?
3 out of 5.
4.
Should be 4 out of 5. So it's 2 out of 5, plus 1 out of 5, plus 1 out of 5. 2, 3, 4 out of 5.
Rain is 3 out of 5.
Yes. This whole thing is my rain.
Okay.
So the whole bubble for rain is 3 out of 5, which means I gotta add my probability of just rain and the probability of rain and lightning. So be careful with that. So this one was a little bit slightly different way to approach this problem when we are given the probabilities. Okay, a little bit different. Well, what's the probability that nothing, or that the sporting event will carry on with no rain, no lightning, no anything? How do you get 1 out of 5?
Because if it's 4 out of 5, the chance is gone out.
Right.
Lose 1 out of 5.
Because here, my universal set is my day in the life of whoever this is. Okay, so when I add up everything in my universal set, what should the probability be?
5 out of 5.
5 out of 5, or 1. And if we said that 2, 3, 4 out of 5 is inside rain, lightning, or both, then 1 out of 5 is no rain, no lightning at all. Okay. That last part was not on here, but expect those types of questions. Okay. The probability of not A, or not B, or not intersection of A and B. Okay, so all of those things.
Do you add one of them up and then subtract the, so could you use that one?
Sure you could, because we definitely could have done this because we had the probability of rain. Well, the probability of rain, 3 out of 5. Probability of lightning, 2 out of 5. Minus the probability of both, which is 1 out of 5. So we certainly could have taken our formula for this. Well, 3 out of 5 plus 2 out of 5, 5 out of 5, minus 1 out of 5, which leaves 4 out of 5. Okay, works that way. Any others? Pretty straightforward with this. Okay, question 8?
7, 8.
7 and 8. Okay.
All you guys will turn
Oh. All right, let's go to numerical order. Determine the probability that the card drawn from the deck is red or face card. Okay, well, we're established the fact that we're dealing with a standard deck of cards, 52 cards, that we are looking at a card being drawn. What are my 2 events?
red and face card.
Okay, so we're looking at
That would be 2
A, that it is red, B, that it's a face card. Okay, well, what is the probability that the card chosen is red,
2.
which is
It should be 3 out of 52.
not 3?
Shouldn't, is it our ace also?
Well, we're not dealing with these, we're not dealing with that.
Oh,
Not red.
Red. 1/2.
1/2 or 26 out of 52. I'm holding off reducing until the end, simply because if we keep everything out of the same fraction, it's easier to add and subtract. Well, how many face cards are there?
16 out of 52.
How do you get 16? 4 in each set. How many sets are there?
4.
Clubs, spades, hearts, diamonds. 4, 8, 12, 16. Okay, now, are these 2 events Mutually exclusive or inclusive?
Inclusive.
How do you know?
Because
Can you have a red face card?
yes.
Yes. So we need to find the probability of a red face card. How many red face cards are there? 8. Out of how many? Okay. Well, now,
We add them.
26 plus 16 minus 8, all out of 52. What's 26 plus 16?
42.
42 minus 8.
36.
36.
Sorry, 34.
I was going to say,
No, you believe this.
trust me. 16 minus 8 is not much. 16 minus 8 is 8. 26 and 8. 16 is 34. Well, what do we go to the 34 and 52?
Huh?
2. How many times 2 go to 34? 34 divided by 2 is 17. 52 divided by 2? 26, 17, 26.
Doesn't it go by?
All right, number 8. Find the probability of 2 dice being tossed and showing a sum of 6 or a sum of 9. Uh-oh. Okay, so we could list it. If you get a 1, then you have to get a 5. What happens if you roll a 2 on the first one? You gotta get a 4. What happens if you roll a 3? 3. What happens if you roll a 2? 2. You get, 4, you gotta get a 2. What happens if you roll a 5? You get a 1. Can I roll a 6 on the first one?
Yes.
You can?
No.
Because I have to add the 2 die. I can't because if I roll a 6, I would have to roll a what on the second one? 0 in order to get a 6.
Yes.
Okay? Now, we want to roll to get a 9.
1, 8.
Okay? Can't get an 8. So 1 is 1. 2. Can I roll a 2?
Yes. Yeah. What was 6?
No, before.
Because what's 2 plus 6? 8, not 9.
So it goes up to 3.
So I go 3. I roll a 3, then I gotta get a 6. Can I roll a 4?
Yeah.
And I have to roll a
5.
5. Can I roll a 5? And then I roll a 4. Can I roll a 6? And then I roll a 3. Well, if this is my A and this is my B, how many different possibilities are there when I roll a die? 2 dice, I should say.
Well, then mutually exclusive.
Hold on a second. How many possibilities are there? 36 different possibilities. Why?
If you multiply 6 and 6, there's 6 possibilities and 6 possibilities.
Because each die is what?
Each dice.
How would you explain the probability of each die?
1 out of 6.
Do they depend on each other?
Oh, I know.
No, they are
You're in.
independent. And what do we do with independent probabilities? Multiply. Okay, so there are 6 different possibilities for the first one to land on. There are 6 different possibilities for the second one to land on. 6 times 6 is 36. Well, in this case, what is the probability of A? Well, how many choices did we get out of this 36? 5 out of 36. What's the probability of B? 4 out of 36. Are these inclusive or exclusive?
Exclusive.
How do you know they're exclusive?
None of the chances are the same.
How do you know? Is it possible to roll a sum of 6 and a sum of 9 at the same time? No. When you roll them, the sum is what? It's set. Okay? And it can't be 2 different values at the same time. So we are looking at exclusive event. So what's the probability of that? Which is?
1 out of 4.
1 out of 4. All right. Now we got the old juices flowing. Yeah, hopefully. Some of you, I don't know, I doubt it. Maybe. On a good day. Okay. So, oops, sorry. This table's messed up. All right. So you see number 3 and number 5. Yes, barely. Okay. It's a very light gray. Copied and pasted those in there. Come back to those. Those are dealing with cards and dice. Now, to get back to where we started with independent events. How do we calculate the probability of independent events? We just said this, by the way. This is how I know you guys are all paying attention more to your screens and what's on your screens than what's coming out of the mouth. Because even the person that said this doesn't even realize that they said it. What was the question again? Exactly. How do you calculate the probability of independent events?
It says it right there.
No, that does not. We multiply. Multiply what? Probability of the 2 events. Okay? If you know that they are independent. Problem is we don't always know they're independent. Okay? Which is a big thing on your IB. It will say, show that these 2 events are independent.
We use this formula.
Which means that you have to use this formula. Okay? You do not automatically take the 2, multiply them together all the time. Okay? Excuse me?
So instead of find the probability of independence, we use that.
Sometimes. What happens if we know they're independent? This is why I pay attention. I know. But you asked the question that we've already answered because we were looking at what's on the screen.
Wait, what was the question?
Just want you to realize that this is being answered. And I will certainly show you how to
Mom.
So,
Mom.
let's review a little bit. How do you calculate the probability of 2 independent events if you know they are independent? Multiply them. What happens if you are trying to show that 2 events are independent?
We use this formula.
Well, we use this one. Well, what's different about this one?
You subtract first.
On subtract. That's not subtract.
I can't see it.
That is an equal sign. Okay, that's
That's
why.
a really thick equal sign.
Yeah. Almost as thick as some of your skulls.
I hope this is being videotaped.
It is, because it comes from my heart.
Yeah, you got evidence.
Evidence that I love.
Ah, wink, wink. He winks at me and hits me in the back of the head. Ow!
So, what's different about this? What does it say? See. What is that first part to the left of that equal sign? The intersection, the overlap. So it's saying that if we have 2 situations, if we have this part right here,
That minus that times that.
That equals a.
Middle bit minus.
no minus.
A.
That's an equal sign.
Oh, that's a, oh. What?
See, this is also why we pay attention. We've said that's an equal sign
Well,
5 times.
it's not.
Yes, that's actually.
So it's like the middle part, is the A and B.
Yes, it's the middle part, it's the overlap. So, where have we talked about that overlap? So, some mutually inclusive events are independent. Not all of them. The only ones that are mutually inclusive and independent are the ones that this overlap is equal to the probability of A times the probability of B, which is extremely, extremely important because when you're trying to prove or trying to, in IB speak, show that A and B are independent, that's what you need to show. Okay? When you're trying to show that event A and event B are independent, you need to show that the product of their probabilities is equal to the probability of the intersection.
Oh, that makes sense.
Okay, so be careful. Now, if we look at this, right? If you look at this and keep the A and the B. If we let U, our universal set, B, the natural numbers from 1 to 20. Natural numbers, what are natural numbers? Counting numbers, right? So our counting numbers from 1 to 20. So our A, multiples of 3. And B is multiples of 4. Are A and B independent? Well, what do we get for A? So, what are the multiples of 3? 3, 6, 9, 12, 15, 18. Can I keep going? No, because the next one is about 20. What about the multiples of 4?
4, 8, 12, 16, 20.
Okay, so first thing, are they where we need them to be? Are they mutually inclusive? Is there an overlap? Okay, so there is an overlap. 3, no. 6, no. 9, no. 12, though. 15, no, no, no. Oh, okay, so we're looking at a situation. If this is A, and this is B, and this is my universal set, because that's the other part that you will be asked. You will be asked to draw a Venn diagram illustrating the probabilities. Okay? So we need to be able to draw this thing in Venn diagram form. Well, correctly place all of the values. Well, if we're looking at all the values, we're looking at 1, 2, 3, 4, all the way up to 20. Where does 1 go? Outside. How about 2? Outside. How about 3?
Inside A.
Inside A. Is it in the overlap? No. This is the easiest place to start. What goes in the overlap? Only 12. What about all the other things in there? Where do they go? They go just out here. 3, 6, 9, 15, 18. 12 is the only one in A that belongs in this overlap. Same thing for B. 4, 8, 16, and 20. 12 is our unit. So we need to fill in 1, 2, 3, 4. There's 5 in here.
No, that's A.
5 is an A.
No,
6, 7, 8,
inside B.
9,
Inside A.
10,
Universe.
11, 12, 13, 14,
Universe.
15, 16, 17, 18, 19, and then 20. So we've correctly placed all of these values. I know I didn't ask for that, but it's good practice to do this because you will be asked to correctly place all of the values in this example. Well, now, we need to determine whether these things are independent or not. So I need to figure this out. What is the probability of the intersection? So we need to find the probability of A, we need to find the probability of B, and we need to find the probability of A intersect B. Where do you want to start? A is 5. What's the probability of A? How do you get 6? Well, you've got 1, 2, 3, 4, 5, 6 out of how many possible? 20. What's the probability of B? 5 out of 20. What's the probability of A intersect B? 1 out of 20. Well, how do I determine if they are independent or not? What's that formula tell me to do?
Multiply the probability of A upon B.
Okay, so if I take the probability of A and I multiply it by the probability of B, what's the probability of A?
6.
6 out of 20. What's the probability of B?
5. Yes.
What do I get when I multiply 6 out of 20 and 5 out of 20?
30.
Not 40, not 20. I will agree, you get 30.
30 over 40. No, 400.
30 over 400, which will reduce to 3 out of 40. Well, now what?
Well, we're gonna compare it to the intersection, right?
Okay, so we compare it to the intersection. So the probability of A intersect B, does that equal the probability of A times the probability of B? Does 1 out of 20 equal 3 out of 40? No, they do not equal. Are they independent? They're not independent. Okay? In order for them to be independent, what do you know has to happen here? It has to be a true statement. It has to be something that is equal. Okay? Since 1 out of 20 is not equal to 3 out of 40, that, in other words, this is a false statement. Okay? We can't have false statements. So it's not independent. There you go. So now we've got, if we know events are independent, if we know they're independent, then we multiply. If they're mutually exclusive, then we add. If they're mutually inclusive, then we add and subtract the overlap. But then in the mutually inclusive, I also have to figure out if they are independent or not. Now,
Well,
what do you know the overlap is here? What is the overlap here?
there's no.
So what's the probability of the overlap?
0.
0. So what's the probability of the intersection?
0.
So how would you prove that two events are mutually exclusive if you have the probability? What equals 0?
If there's no,
If the
The
intersection is equal to 0, which is also something that you will be asked on the IB. Show that events A and B are mutually exclusive. Well, the way that you would show that they're mutually exclusive is to show that the intersection is equal to what? 0.
how do we show that?
Depends on what the problem, depends on what you're given, okay? But that is that is what you are going to be asked to do, is to show that this value is 0.
But there has to be some way to show that, like, some form of.
Can't you just say it's like?
Well, you can't say it's 0 unless you know it's 0 or prove that it's 0. Because I can say your hair is green, but that doesn't make your hair green.
There's nothing.
That's what I said, depends on what we're given the problems, because there's different ways that we prove that it's equal to 0, depends on what we're given. Does that make sense? I know it's kind of a very vague answer, but it depends on, it's one of those that depends on what we're given in the problem as to how we show it's equal to 0. All right? Okay, so that being the case, so right.
You said mutually exclusive, right? And then they ask for finding the, show that events A and B are mutually exclusive, you just say that E and B equals.
That's what you were, that's what they are asking, yes. Okay. Couple of example problems.
No.
Like I said, these are on your Google Classroom, so you can certainly look on there, or you can look up here. Doesn't matter, boom, go for it.
Why is it not?
Oh, you upset, I didn't put your name up there. I did put your name up there on the problem.
When?
You actually made it into a testimony.
Me too.
The big leagues.
There is some
That's
kind
big.
And then he's the question, he's on a question that we screws everyone up. Why did you betray us, Kevin?
I am a brother.
Oh yeah, our test.
So, okay.
Speaking of which.
Your intros and plans, you will be getting back over the next couple days. If you submitted it to me via email, I will probably submit it back to you via, Classroom.
Okay.
If you submitted it through Classroom, then I will also get it back to you via Classroom.
So basically, we get.
The only reason that I do that is so that I can open it up as a Google Doc and put comments on it or highlights, and then I can share that back with you.
Oh, wait, so I tried.
Oh my.
How do they still?
Because we're not looking at it.
That's already.
Always be looking.
Okay, so we're paying attention.
Ow.
God. Wait till we're done.
It was nice. All about thinking how much.
Yeah. It is, you know, we got one more.
Right.
Oh. There was no mutation, which is, let me see. I don't know why I like gene enzyme. Use a gene.
As you there.
Why would you?
Why did I say
Because the
why did I say why did I?
Yeah, for that, I really just want to be invisible in their lives.
Okay, we figured out this first example. Brianna and Tandy.
They cannot tell.
The local competition probability that Brianna wins the prize for her design is 0.4. Probability that Tanvir wins the prize for his photograph is 0.58. Probability that they both win is 0.25. So the first question that we have to ask ourselves is what?
The probability that either Brianna or Tanvir wins.
Well, what's the very first question we have to ask?
Find the probability of.
Even before we get that,
How much is that?
what was the very first question we've been asking?
Are they independent?
Are they independent or are they even before that?
Are they
Exclusive or inclusive? How do you know inclusive? Not because they took part in the same competition,
Because there's a chance that they can both win.
because there is one of the options that they can both win. Okay? So in other words, there are different levels, or in this case, there's a design prize and there's a photograph prize. It's not just an overall prize. Okay? So we know that we're dealing with mutually inclusive because there's an overlap, because there's a possibility that they both win. All right? Well, what is that first thing to say? How do we find the probability that either Brianna or Tanvir win? Do I take 0.25 from both? Okay, so we take probability of Brianna winning plus the probability of Tanvir winning minus the probability of probability of Brianna and Tanvir winning. Well, what's the probability of Brianna winning? 0.4. What's the probability of Tanvir winning? 0.58. What's the probability they both win? 0.25. So, what is the probability that either of them? Well, 0.4 plus 0.58 is 0.98 minus 0.25. 0.473. Now, are the two events independent? How can we tell if the two are independent? Okay, because we said that the probability of Brianna and Tanvir winning, the combination, must equal the probability of Brianna, the product of Brianna and Tanvir winning. What do you mean?
I did a calculation.
Did what calculation?
I multiply against probability.
What is 0.4 times 0.58?
0.23.
0.232. 0.25 does not equal 0.232. So are these two independent? No. And like you said, they're close, but when we're dealing with this, close is not good enough. We need to be exact. Okay.
The 0.249.
0.249.
Technically, if you're rounding to two decimal places.
Well, it depends on it would depend on the significance that you use. If you're looking at 2 decimal places or 3 significant figures or something like that, you're not going to see that on the test. It's because it would come up. But if you do see them, then the justification you could give is yes, because 0.25 is only 2 significant figures. 0.249, which is 2 significant figures, is 0.25. So yes, therefore, it can only be as significant as the least significant number. And therefore, they both equal. Okay. All right, we did that one. Do the next one.
Hold on. It's right here.
It's not a break.
I thought I saw you doing something.
Yeah,
I was like, what?
it was a student.
Yeah.
It was a student.
It was me.
It was a student.
Hey,
That's it. Oh,
What are you doing?
I must see this.
Don't get back in place.
Close the door. She's on her way.
Close the door. Go talk to her. You know, where's the bathroom?
Where's the bathroom? Where's the bathroom?
Sorry?
When we were in necessity,
Yeah. Yeah.
Teach you guys to lead during my class.
Oh, wait, I'm missing my notebook too. It's in my notebook.
can I erase this so I can move it up?
Sure.
For those of you that are not one walk
Let me drink it like it.
I wasn't implying anything. I said for those of you that are not from Google Classroom, like this one.
I think it was me. What did you see? It's like you. I'm the person. It's like you.
She's so weird.
Was that your baby photo?
Oh!
Your friend said it looked like you.
It's white and blonde hair. The boy. You can't.
Sounds like something.
Just because it's
Alright, who can go do part A? This is very much one of those questions that we just asked ourselves. How do we decide whether two events are mutually exclusive? How do you show two events are mutually exclusive? We could do a Venn diagram. What would have to happen in the Venn diagram? If you're going to do a Venn diagram, what would have to happen? What do you know about mutually exclusive events?
They don't interlap.
They do not overlap. So if you're going to do a Venn diagram, what has to happen?
They're 2 weeks later.
Okay? Or if you drew them as overlapping circles, what would be in the intersection? Okay, fair enough. Let me rephrase this. So when you would set this up and say, okay, I'm going to do a Venn diagram, and you drew it like this,
Or you could put,
what would happen?
you could put the number in each event, and if there is nothing in the intersection, then you could say it's mutually exclusive.
There you go. Okay, if I drew this, giving the option for the overlap. After I got through all of my data, nothing would be in this overlap. So then I could readjust it and we would have two separate circles or whatever for even that. Can we do that? We could, because we have all of the values in this thing.
You make a shot from here.
Good, but I didn't feel like.
Sure.
He also is discussing this.
I'm terrible at basketball.
Nice.
Okay, I had this in my hand.
Excuses, all good excuses.
I really did do that.
Just don't pass it.
Seriously, where's it?
So well, at least I can still read.
Best excuse.
I was just eating for the rent.
Oh, that's the only logical reason.
Yes, that's testing.
Hi, nice block.
Test. Not test, a quiz, no way. Quiz.
No.
Such math, not study.
Oh.
So far, I was supposed to.
No.
I do it too.
You said test.
Do it.
Oh.
And you
Yeah,
mix
we
it.
did. Women.
And you mix it. This is just hope to agree.
Or also computing.
I don't know, you could come just play for the Filipino national basketball team.
I guess if you're from another country, you'll be in
So you're
another
abroad?
country, you think it's
You were wrong?
I'm wrong.
There's no national Oriental. We got like Oriental noodle or Oriental rug. But there's no Oriental people
Originating from like a specific country that we mix.
being the Orient.
You're right. Yeah, endemic.
And then it's technically
No, I think it's constant.
like here.
just.
It means that we can.
All right, we got this done or what? Let's do this.
Oh, I know what we got to do.
Dance party.
There's so much missing.
There's so much to do.
There's so much nothing to do.
Speaking of, you guys, I'm sure you've seen this, but it's my duty to tell you. Your extended essay deadline.
Yeah.
You know, like,
You-
Is that the final thing, like, you can't, we don't do that.
Good.
Correct, you're not good. In other words, as a class, sounds like your extended essays were.
They were.
Yeah.
No, I honestly, I have no idea why they did that. I would have to, if I had to guess, in overlapping.
No, they wanted to do it in class and have their abstract, they forgot to plan it ahead, so they're supposed to do that planning.
Yeah,
I agree.
Please send me email, there'll be no time to plan the abstract thing, I wanted to do this lesson. Yeah, exactly, it's 6 days.
Yeah, but like,
He also said it's for numerous reasons.
everyone else
Well,
had
that's-
to like,
no,
that
okay.
or like what?
See,
We have to do it in
Wait.
We have way too much work to do. I guess you haven't expected to.
Whoa. You do not have all. Oh, that's right. We have all class. Math one, science one,
No, the
history
science
one.
one is.
Next week.
environment that.
That's what the line look, right?
Yes, see, when you start looking at it, you don't have all.
I do, yeah.
You have vinyl.
So I was thinking like, why would you do the same day?
Wait, why is it 218? Why is it?
No, it's not, I was doing the same.
Why is two,
Not up front.
two isn't right?
Oh.
One.
That.
And we can say, can we understand it, even though we got the feedback from there.
That's the whole.
All right.
That is the verb for atmosphere protection extends, that the normal environment is positive for.
Okay, so we are about.
Almost your attendance, like,